Here I'm going to show you how to graph a polynomial function using your calculator. So we're going to use this first example. We're going to graph that on our calculator. So what I'm going to do is I'm going to put x cubed plus 3x squared minus 24x in my y equals on my calculator. So we'll go down here to my calculator. I'm already in y equals. So if I'm starting at the home screen, we're going to go to y equals, and I'm going to put in x cubed plus 3x squared minus 24x, and then I'm going to graph it. And you should get something that looks like this. Now we're kind of zoomed in, we're in the standard window, but I'm going to give you just a way to get the zoom correct for this. So we're always going to start at the standard. So I'm going to go to zoom, and then I'm going to push the number 6 for standard. And you're going to see the same thing because I was already in the standard. And then I'm going to go to zoom, and then I'm going to push the number 0 because 0 is fit. So it's going to fit the function to my window. So this is what it actually looks like when you zoom out. Now, I can use my calculator to find the zeros, the y-intercept, and the relative maxima and minima. So this function, you can see a maximum right here because it's a peak, and a minimum right here because it's a valley. We can determine where the graph crosses the x-axis. You can see 1, 2, 3 points at which it crosses the x-axis. So those are our roots or zeros. So you can use your calculator to actually determine the zeros. If you go to second, trace, and then 0. So I'm going to hit enter, and you get this cursor. And you see it's asking for the left bound. So what I'm going to do is, for the 0 furthest to the left, I'm going to move the cursor. See how I'm pushing the left? I'm going to move it to the left of this 0 and press enter. And you'll notice that your calculator will make a line here. So that's going to be the left boundary where it's going to be looking for a 0. And then I'm going to move the cursor when it says right bound. I'm going to move the cursor to the right of the 0, hit enter. And so now it's going to be looking for a 0 between these two lines. And you can see it's going to be right there. When it says guess, just hit enter. And you'll see your cursor goes to your first 0, which is negative 6.60. So we can write that over here. So we have, for our zeros, negative 6.60. And we can do this for the next two zeros. So if I go to second, trace, 0, now I'm going to be to the left of this next 0. So it doesn't matter exactly where I am as long as I'm to the left of it. So my left bound will be here. I'm going to go to the right of that next 0, hit enter, enter again, and my next 0 is at x equals 0 and y equals 0, so 0, 0. And then we'll do our last one, second, trace, 0. I'm going to make sure I'm to the left of this 0 and to the right of it. Hit enter again, and we get it at 3.6 and 0. Then we would plot these points on our graph. So negative 6.6 and 0 is right around here. 0, 0 is at the origin. And 3.6 and 0 is right around here. Now for our y-intercept, that's when x is 0. So right here, we already know that it's 0. But you can determine that using the calculator if you go to your table. So if I go to second graph, my y-intercept is what is y when x is 0. So you just look at x is 0, y is 0. All right, the last thing we're going to look for are the relative minima and maxima. So if I go to second, trace, and the first thing I'm going to look for is the maximum. And I know that there's a maximum right here because this is a peak. And it says left bound. So I just need to go to the left of the peak of this hill right here. So just somewhere to the left of it. And then I want to go to the right of it. So now it's going to tell me what is the maximum point, what is the highest y value between these two boundaries. So when I hit enter, it'll go to that maximum, and it tells me it's negative 480. Again, we're rounding, so it's to the nearest 10th. So there's a relative maximum at negative 480. And then we know that there's a minimum, because it's a valley, right around here. So to find the minimum, I'm going to do the same thing, except I'm going to choose, so I'm going to go second trace, and then I'm going to choose minimum. I'm going to go to the left. It's asking for the left bound. I'm going to go to the left of the valley, hit enter. I'm going to go to the right of the valley and hit enter. And now it's going to tell me what is the lowest y value between these two boundaries. So when I hit enter, it goes to that minimum point, which is 2, negative 28. So I'll write there's a relative min at 2, negative 28. And we can graph those 2 points, so negative 480 and 2, negative 28. And then I like to just get 2 more points just so that my graph is more precise. So we're going to go below negative 6 on the table. So there's a point at negative 7, negative 28. So I'll go to negative 7, negative 28. I'm a little bit off there, but it's okay. And then there's a point at, so we want to go above positive 3. So there's a point at 580. And then we can fill in all of our points. So we get the the relative max here. We get our relative min here. All of our zeros, and our y-intercept is correct. Now, I think that's it.